Hi everyone! In this video we're going to learn about graphs of the tangent and cotangent functions. Let's start with the tangent function. To understand the nature of the graph of the tangent function, we need to point out that tangent can be written as the ratio sine over cosine. And as with any fraction, we know that whenever denominator is equal to 0, the fraction is undefined. Well, therefore, it means that everywhere cosine of x equals 0, tangent will be undefined. So at those values of x, we'll have to construct asymptotes, lines that graph of the tangent function approaches but never touches or crosses. And since cosine function helps us to determine where to place asymptotes for the graph of the tangent function, so cosine is going to be the guideline function for tangent function. It's going to help us to graph the tangent function. So here it is, the graph of the basic cosine function. Cosine equals 0 at the x-intercept values, or 0 values. And that's where we're going to place asymptotes for the tangent graph. Since graph of the tangent function cannot cross or touch these lines, that means that the graph is not going to be continuous. It will consist of pieces or branches. And those pieces or branches will be in between the asymptotes. Let's try to understand what kind of shape they're going to take. For that, let's see what kind of value the tangent function takes at the midpoints in between the asymptotes, so at pi and at 0. Well, we know that tangent of 0 equals 0, so that means that tangent is going to have point at 0, 0, and tangent of pi also equals 0. So that means that it's going to be another point on the x-axis. So from here we conclude that branches of the tangent function are going to cross the horizontal axis right at the midpoint between two neighboring asymptotes. Well, let's find a few more points to see the behavior of the graph. How about we take this portion between the two asymptotes, between negative pi over 2 and pi over 2, and split each half and half again. So we're going to find the midpoint between 0 and pi over 2. Well, it's going to be pi over 4. And the midpoint between 0 and negative pi over 2, well, negative pi over 4. So what are the tangent values at pi over 4 and negative pi over 4? They are 1 and negative 1 respectively. Let's plot those points. So at pi over 4, tangent value is 1. Here's that point. And at negative pi over 4, tangent value is negative 1. Here it's point. So from here we can see that the branch of the tangent function is going to cross the x-axis right in between the asymptotes, and it will also appear both above the x-axis and below the x-axis. Well, let me show what shape it's going to take. It's going to resemble the shape of the cubic function, if you remember that one from algebra. And here's one more branch. They're all going to have same shape. So in between two neighboring asymptotes, we're going to have one branch of the graph of the tangent function. So what do you think is one period of the tangent function? For that, we need to determine one cycle of the tangent function first. Remember, one cycle is the piece of the graph that you can copy and paste and recreate the entire graph. Well, if all branches are the same, then one branch would be enough to recreate the entire graph if I copy and paste it, right? So that is one period. And if we calculate it, 3 pi over 2 minus pi over 2, that is 2 pi over 2 or just pi. And if we make connection with the period of the guideline function, well, it's going to be exactly half of that, because remember, the period of the basic cosine function is 2 pi. Well, period of the corresponding tangent function is going to be half of that, in this case is pi. In other words, within one cycle of the guideline function, we can fit 2 cycles of the corresponding tangent function. Now let's talk about cotangent function. So idea for analyzing and constructing the graph of the cotangent function is very similar to the tangent function. First, we need to know that cotangent function can be written as cosine over sine. And since whenever the denominator equals 0, the fraction becomes undefined, For all values of x that make sine function equals 0, cotangent will be undefined for those values of x, and that's where we're going to sketch asymptotes. So for cotangent, the guideline function is the sine function. Here it's graph. We just said that everywhere the sine function equals 0, and these are points that we call x-intercepts or 0 points. Here at 0, at pi, at 2 pi, cotangent function is going to be undefined. Therefore, we're going to place the asymptotes at those values. Next, let's investigate the behavior of the cotangent function in between the asymptotes. I can already give you a hint that the shape of the graph of the cotangent function is going to be similar to the shape of the graph of the tangent function. Well, with one difference. So let's find a few points. So first of all, in between the asymptotes at pi over 2 and 3 pi over 2, cotangent values are zeros. That means that the branches of the cotangent function will cross the x-axis at those points, right in the middle between the asymptotes. And we can also see that if we split each half in half, so between 0 and pi over 2 we get pi over 4, and between pi over 2 and pi we get 3 pi over 4. At those x values, cotangent takes value 1 and negative 1 respectively. So at pi over 4, cotangent equals 1. Here's this point. And at 3 pi over 4, cotangent equals negative 1. Here's this point. So the graph of the cotangent function will appear above the x-axis first, then it's going to cross the x-axis, and then it will appear below the x-axis. Here's the shape that one branch of the cotangent function is going to take. Again, it resembles the graph of the cubic function, but how is this branch different from the branches of the tangent function? Well, it's the direction. Notice how it's decreasing. So if you travel along that graph from left to right, you're going to be going down, so it's decreasing. When for the tangent function, the graphs or the branches of the graph are increasing if you travel along them from left to right. So that's going to be the difference. And of course, the second branch looks the same, and we can keep going and construct more branches, moving to the right or moving to the left. So one cycle of the cotangent function is one branch, and in this case, the period is going to be pi. From pi to 2 pi, we can see how it's pi, and again, it's half of the period of the guideline function, which has period 2 pi. Let's summarize the steps for graphing tangent or cotangent function. First, you identify the guideline function. Well, that's when you think about tangent as sine over cosine, or about cotangent as cosine over sine. And whatever function is in the denominator on the bottom, that's going to be the guideline function. At all points that we call zeros of the guideline function, well, they're x-intercepts, we need to place vertical asymptotes. These are the lines that branches of the cotangent and tangent functions will never cross or touch. And in between the asymptotes, we're going to have branches of the tangent and cotangent function that looks like, well, some people call them snakes, or resemble cubic function, and they will cross the x-axis right in between the asymptotes. And after that, you can quickly sketch those branches. If you remember that the branches of the tangent function are increasing, and the branches of the cotangent function are decreasing. Or you can always find points halfway between the midpoint and each asymptote, and plug them into the given function to find 2 additional points. Now, what we just said about the direction of the tangent and cotangent graphs is shown here. Tangent is increasing, cotangent is decreasing, has decreasing branches. But we can also have reflected tangent and cotangent graphs. Well, that's when we see negative sign in the front. What's going to be different in that case? What's going to change is just the direction. If you have reflected tangent function, then the direction of the branches of the graph are changing to decreasing. And you can try that in your mind. Try to reflect one of the branches. In other words, wherever it's above, the x-axis will appear below. And whatever is below the x-axis will appear above. Then you'll see how it's just the direction that really switches. And since the graph of the cotangent function has decreasing direction, once we have the reflected cotangent function, its branches have increasing direction. We're going to do a few examples in the next video.